We're excited to be here, and I think I'm the first non-PhD since Laura this morning, so it will be a bit more different kind of presentation, but super excited to be here and tell you a bit more about GlycanAge and what we do and the type of research we do. And just to start, GlycanAge is a startup, as Laura mentioned, and we are a spin-off of a research institute, GycanAge, which is located in Croatia, and it's the biggest glycobiology research institute in the world, but I will get to that in a moment. Now, before I start talking about women's health and which area of women's health we study and what we've done so far, I will start with why we study glycans and why they are important. And to start on that, I will show this, which I don't think surprised anyone here. And that's how we detect diseases. And how we detect diseases these days is we usually wait a bit too long, so we detect them when there is already symptoms or organ damage. And we know that actually when diseases start developing is much earlier, and it actually starts with biological aging. And we also know that men and women, they have different health span and lifespan. Again, not something new for anyone here. And I think we already discussed that, maybe, I don't remember who talked about that exactly, but definitely we know that women live longer, but they don't necessarily spend these extra years they have in good health. So actually they spend more time with chronic conditions, which is definitely not something we would like to see. And when we look at glycans and GlycanAge, with GlycanAge, we see that men and women actually also age differently. And here we have these 5 populations of different glycans structures. And what we see is that we have the male line, which is blue, and the female line, which is red. And we see that men more or less age more linearly, while women age, of course, differently. And I think we covered this already. Like women age slowly when they're younger, and then they catch up when they start going through perimenopause and menopause, and it's a very drastic shift. But I will get to this in a bit. Now, before I get to menopause and hormones, maybe a bit of introduction about why glycans, why GlycanAge, what we do, and how we came up to be. And actually, glycobiology is quite a niche field. It was not necessarily very much studied and developed before the last couple of decades. There are, I think, around 100 glycobiology scientists in the world, and just for comparison, I think there are 100,000 neuroscientists. So we can see how very little this field still is. But that doesn't necessarily make it less important, and with technological advancements, we understand that we can see more and more insights from glycans. And this is something that was published 10 years ago, and this was a paper that identified glycans and the glycan clock as a very good clock for aging and identifying molecular aging. And the interesting thing is that it was published on the same day when Steve Horvath's published his Horvath's clock. And we had this celebration of the 10th year anniversary of both clocks last year. In Robin, we had this amazing longevity symposium, and there is a QR code, so you can scan it, you can see some of the talks, but it was, a very, very nice experience. And now if I tell you that glycans and GlycanAge is a very cool biomarker and it's better than some of the others, I will kind of seem biased. But actually, we do have a lot of research to back that, and there are 30 years of research where the chief scientific officer of GlycanAge and the person who actually published his first paper on the glycan clock was working on the glycobiology and understanding better glycans. And we have more than 300 scientific papers. Most of this was funded through European grants, and the research institute keeps on being funded mostly through grants. And here there is a study from the biomarker consortium, which shows that GlycanAge is actually one of the biomarkers and aging clocks that is associated with multiple diseases, and also that is commercially used to track responsive to lifestyle changes. So it has its benefits. And here there is another comparison. So that was a study that Professor Riccardo Marioni presented at that 10th year celebration of the aging clocks last year. And it shows, compares GlycanAge, GreenAge, which is the methylation clock, as well as some other clocks. And it's a cohort of, I think, 1,000 people, so not too big. But it shows that GlycanAge is great at predicting incident diabetes, and then also quite good in predicting all-cause mortality. And why do we care about glycans, and what do glycans actually measure? It's inflammation, and I think that Mario talked about inflammation a lot, so I don't need to cover it again. We know that inflammation was only recently added to the hallmarks of aging, but we talk about inflammation for quite some time. And I think the term was coined in 2006, so we know quite well that inflammation is important, and we better measure it and try to tackle it. Now, what are glycans? So, glycans are carbohydrates. They exist on every cell surface, and they develop together with proteins and lipids, and they facilitate cell-to-cell communication. That's like the highest overview. And before I get more in that, there is a good note to make, which is the difference between glycation and glycosylation. So it's something that's very often confused. Glycation is a quite random process. It's the damage on the cells from like eating too much carbs when we see these glucose spikes, and it's a process that we don't really care about within GlycanAge. We measure glycosylation, which is a controlled and regulated process where certain glycan structures are set to their locations on lipids and proteins. And while some of you may not have heard or know a lot about glycans, actually their role is very important in a lot of biological processes. I won't go into details, but they're important. Like they define our blood groups. They are cancer cells use glycans to, deceive the immune surveillance. They are quite important for conception, but most importantly, and what we mostly care about, is that glycans are the way our immune system communicates. And to build on that, from now on, what we will be talking about and what we are measuring within GlycanAge is IgG glycans, so glycans on immunoglobulin G. And what we know is that there are anti-inflammatory and pro-inflammatory glycans. And the ratio of those glycans will change with health, and also with aging, with physiological health, and also with genetics. So we know that glycans and GlycanAge are at 40% heritable. So genetics also plays quite a big role. How it works and what we measure exactly is this individual glycan profile that every person has. So for example, this is someone's profile, glycan profile. We measure these 27 peaks. And as mentioned, we know that this is to part heritable, but also very much depend on lifestyle choices and other modifiable factors. But we go beyond just measuring aging and chronic inflammation on a very high level and generic level. And we have increasingly more studies that look into specific glycan profiles of specific diseases. And for example, this is the glycan profile of rheumatoid arthritis. And what we do after that is we can compare every individual person's glycan profile at any point in time with the glycan profile of specific disease. And then we can see whether there is overlap and to what extent this overlap is. Now, whether this means that this person has this disease, not necessarily, because we know that glycan changes will occur up to 10 years before the actual disease starts developing. So it's really more for prevention, and also, whether you will develop this disease or not will also depend on how you live your life in these next 10 years. So it's, in a sense, it means that you're at risk, but doesn't necessarily mean that you will develop this disease. And how we came to this conclusion and to this type of measurement, especially in terms of diseases, is through this study that was published, I think, in June last year. And it reviewed, I think, over 300 papers, and concluded that glycans have the potential to actually detect quite early more than 70 diseases. And I say have the potential because, well, they can, but we still need a lot more research and a lot more data to be able to make any diagnostic, prognostic claims and all that. And as I mentioned, the interesting thing is that they change up to 10 years in advance, so they could be a very good tool for prevention. And here are some of these diseases, and we can see we have hypertension, cardiovascular events, type 2 diabetes, rheumatoid arthritis, and for some we know that the AUC, so it's already very good. We want it to be closer to 1. And for example, for hypertension, rheumatoid arthritis, we know that we have data that these are already very good. For others, like CVD events and type 2 diabetes, we know that glycans in combination with some other biomarkers could bring us to this higher accuracy. And then we also know what's the prediction time, the average prediction time. So on average, it's between 6 and 10 years. So actually, this happens way before the disease is actually developed. But now, let's go back to where we started and basically what we're doing in women's health and what we found in women's health. And we've mostly done research until this day around menopause and hormones. And what we know is, and I guess like we've been discussing this in different contexts a lot today, but we know that with menopause there is this dramatic shift of glycans from being, let's say, young to old. So the increase is 2 times quicker than in any other period in women's life. So it's really, really dramatic. And of course, it's mostly driven by hormones. And here we're showing just like a graph of all of the hormonal changes that impact women through their life. And now we'll look at a couple of those events, maybe the menstrual cycle, pregnancy, and then of course we mostly will focus on menopause. What we see with menstrual cycle is that, so this is a study we did it's again a small cohort, 70 women in Japan. And they were, for a couple of months, they were tested weekly to see whether there are changes, glycan changes which were happening during their menstrual cycle and driven by their menstrual cycle. And what we saw is that there are such changes, but they're very, very small, so it's 1% variability. So we can say that the menstrual cycle is not something that really affects glycans. This is definitely not the case with pregnancy. Now, this is a case study, but we also have a couple of papers that are discussing that, and we know that during pregnancy, the biological age, the GlycanAge, or the inflammation level, as we want to name it, is increasing, so it's quite suppressed. Then, post-pregnancy, we see this, again, like quite huge increase. And then usually we see glycans go back to anti-inflammatory state after breastfeeding when also hormones stabilize. And finally, we have menopause and perimenopause and menopause. Now, the problem is that with menstrual cycle and with pregnancy, the changes in hormones are temporary. And now with menopause, these changes in hormones are permanent. So some of the things that come with menopause will stick around. So this could be fat distribution, inflammation, glucose metabolism, so on and so forth. So we still don't have something that can really delay it. We've heard a lot of cool things that hopefully can come to be and will help us delay it. But as it stands now, we don't have that solution on the market. And we know that estrogen is actually very important and very much connected with systemic inflammation. And the lack of estrogen, especially after menopause, is linked to increased systemic inflammation in the body. And we know how much inflammation is tied to chronic diseases and what it can do to the health span of every woman. On top of that, we also know that menopause comes with a lot of symptoms. So I think there are 70 documented symptoms for menopause. There are the popular ones like hot flashes, but also joint pains, lack of sleep, and a lot of other symptoms. So women are actually not having a very nice time while they're going through perimenopause and menopause, and this is also something that needs to be tackled. And now we have a solution, but it's a quite controversial solution, and a not very much studied one, and that's hormone replacement therapy. There are some studies that say that hormone replacement therapy can actually improve the health span of a woman, that it has good beneficial effects on bone health, cardiovascular health, type 2 diabetes, and even can decrease the use of antidepressants. So really a wide spectrum of things that it can benefit. And we also have some studies that explore the different effects of HRT. So here is a review recently published in Lancet. And when we look at where the benefits are biggest, it's in diabetes and in all-cause mortality. However, we know that the biggest problem with HRT is the increased risk of breast cancer that was very heavily publicized. And there are a lot of women who are afraid of going on HRT, even if recommended by a physician, because they fear that they may develop breast cancer. Now, this is not unreasonable. We know that when a woman is on estrogen and progesterone together, which is the bottom graph, there is an increased risk of breast cancer. We also know that estrogen alone does not increase the risk of breast cancer, but we need way more research to understand what the effects of HRT actually are. And we're doing this research, but it's, as always, we need more funding and more research to do more of that. This is a study that we did, and it's, again, a very small cohort of 40 women. And we collaborated with the UK Menopause Clinic to do this research. And these around 40 women, they were prescribed HRT, and they were consulted by a physician on how to tailor the dosage of HRT and all that. And we see that, now this is still not published, just note that we are waiting the data for year 2 to publish it. But the preliminary data shows that for everyone but 2 women, the biological age is decreasing, so the levels of chronic inflammation are decreasing after the HRT treatment. Now we have these 2 cases for which we see an increase, and we still lack the clinical data to better understand what is driving the increase in inflammation for those 2. But once we get the full data set, before we publish, we will of course discuss this as well. And now, I won't go into much detail into this part, because we are talking about women's health and not necessarily men's health. But we've done some research that actually shows that estrogen can have quite a positive effect for men's health as well. We have a study which is looking at testosterone and the effect of testosterone together with aromatase inhibitors and without it. And we see again that estrogen actually plays quite an important part in men's health and should not be undermined. And we also, for men and women, we have a lot of cases from the clinics. So here is a male case where we see that without the aromatase inhibitors and with lower dosage of testosterone, again, the levels of chronic inflammation could be decreasing. So a lot to be studied around the effects of estrogen. And finally, this is a study, another very interesting study. It was a longitudinal one where we're looking at a cohort of HIV patients. And during the course of the study, some of them transitioned to women. And as they were transitioning to women, we see that their glycans changed from pro-inflammatory to anti-inflammatory, and even there was some effect on the severity of their symptoms, which was, again, quite interesting. And just to finish on that note, so here is a study on an NIA study, which was looking at genetically identical mice. And we saw that when those mice were given estradiol, their lifespan increased with 12%. And we're discussing it just for perspective, because this is the increase in lifespan that a lot of repamycin studies are also discussing. However, we know that repamycin has a lot of side effects, but it is very, very, very heavily researched, and a lot of money are going into researching it further. While this is definitely not the case with estrogen, so we still know very much about it. Something that I don't have on the slide, but we did recently, is looking at cardiovascular diseases for men and women. We see that there is quite a gap as well, where for women the diagnosis comes later, the severity of the symptoms is also higher, and there is this gap. There is a big discussion whether the different hormone profiles could play a significant role, and estrogen and CBD is quite a big topic, but as with every other topic around women's health, not enough studied and researched. And I will end with another summary of glycans and why they are important and why they are a great tool that will be further, hopefully further researched, is that they are great for predicting diseases, and they could do that in advance, 10 years in advance. And they're also quite good in personalized and precision medicine, because they can help really track the effect of different interventions, therapies, lifestyle changes to your health and to your body. And just to maybe make a connection with Linney's presentation that will follow, we are about to also launch a study with Linney, which will be looking at, we'll be using IgG glycans to see whether they will be used as a tool for ovarian aging. We still don't know, but hopefully the study can commence soon, and we can also find a bit more around that. And overall, we are quite open to any studies. We are publishing around 30 papers per year, and here is a QR code you can scan, and you can find more about all our publications.